Okay, welcome. We're on excircles of a triangle. So from the definition, let's define that an excircle is a circle that is tangent to the sides of a triangle and also to the extensions of the other two sides. So let's use a diagram, meaning that we'll have three excircles. Every triangle has three excircles. Okay. So do you see it? We have three circles, and each of them is tangent to the side of a triangle and also to the extension if we extend the other two sides. So that's what we call an excircle. Get the area of this triangle in terms of the radius of the circle. Because I'm using the smallest circle. So let me add some auxiliary lines. So I've added this. If we call this triangle, so you see that if I want to get the area of this ABC, you add triangle O, the area of triangle OBC and that of OAC, and subtract OBA. Do you get? We now get this. So we see that area triangle ABC is area of triangle OAC plus area of triangle OBC minus area of triangle OAB. That's it. So let's introduce extra line, because we know that area is half base times height. So let's introduce the height of the triangle. I'm fine. Okay, no need. The other one is the same. Okay, I've introduced two extra lines. And what's the line? You see that this line is the radius of this circle. Yes. So let's call it R subscript C, because this is C. Let's decide here be C, this be A, and this B, this A. So let's call the radius of the S radius to be R subscript C, which is also R subscript C. This is also R subscript C, and it's perpendicular. You know the radius is always perpendicular to the tangent line, so this is nice. So that happens to be our height. So we see that the area of the triangle is half OAC. The height is ROC, half base. The base is O, the base is B, and the height is ROC plus half OBC. The base is A, and the height is still ROC, R subscript C, minus half the base of this is C, ROC. That's the height. The same from the diagram. That's it. So what do you notice? We can factor ROC. We now have half B plus half A minus half C. And we can write this as RC B plus A minus C over 2. We are still correct. Okay, but we can still write this as, because we want to introduce the semi-perimeter of the triangle, we can write this as A plus B plus C minus 2C, yes, because C minus 2C is minus C over 2, which is the same as RC A plus B plus C over 2 is the semi-perimeter. Yes. Why 2C divided by 2 is C. So do you get A plus B plus C over 2 is our semi-perimeter, where is A plus B plus C over 2 our semi-perimeter. Therefore, the area of a triangle ABC is equal to R subscript C, that's the S radius times the semi-perimeter minus the side that is tangent to that. So that's it. So we can still relate it to others. So if we call this one to be, if we extend this, let's call this R subscript B. Why this one? R subscript A. So that same logic, you can see that the area will also be R subscript A x minus A, or R subscript B S minus B. So that's the formula for the area of a triangle given the radius of the S circle. Okay, let's look at this question. Find the radius of the smallest S circle of a triangle of side 5, 6, and 7. Okay, before we solve this question, we need to know the meaning of S circle and S circle. An S circle is a circle that is tangent to the side of a triangle and also the extension of the other two sides. So let me use a diagram so that you see what I'm saying. So see it, we have each triangle has 3 S circles, since a triangle has 3 sides. So if you notice, each of the circles is tangent to the triangle, to the side of a triangle, and also to the extension of the other two sides. And common sense will now tell us that the smaller the side, the smaller the S circle. So from here, we are now asked to find the radius of the circle that is tangent to the side of length 5, since that's the smallest side here. And there is a formula connecting the area of any triangle with its S radius. So the area of any triangle is always equal to the S radii. Let me use R subscript A for the one tangent to side A. So that's it. Or if I'm using side B, X minus B, or if I'm using side C, S minus C, where R, A, B, C are the S radii. S is the semi-perimeter, which is the sum of the sides over 2. So that is it. So I'm looking for the one that for 5, because 5 is the smallest side. So we know that area of a triangle is always the use of Heron's formula, times x minus a times x minus b times s minus c, all in square root. So let's calculate each of them. So semi-perimeter is 5 plus 6 plus 7 over 2, which is 9. Y s minus a, so x minus a will be 9 minus 5, which is 4. X minus b is 9 minus 6, which is 3. And x minus c, which is 9 minus 7, which is 2. Therefore, the area of triangle is now square root of 9 times 4 times 3 times 2. So 9 has a square root, perfect square root. 4 has, so 3 times 4 is 6, so I have 6 root 6. So therefore, remember, we're asked to find the radius of the smallest S circle. So the smallest S radius is the one that is tangent to side 5, because 5 is the smallest side. Therefore, let's call it R. Let's take R subscript A. So we have area of the triangle over x minus a, which is area is 6 root 6 over the semi-perimeter is 9 minus 4, which is 6 root 6 over 4. So I have 3 over 2 root 6. So that's our answer, option A. So it's a very tricky question. Thank you.